Oh, hello again. So this is structural analysis made fun and easy. University of Bolton, Western International College, FZE, BN Civil Engineering Semester 1, Exam 1617, Maths and Structural Analysis, CEI 4011. This is question 2, simple pin jointed truss analysis, statical determinancy. Equations of equilibrium of joints, part 2 of not sure yet. Probably going to try and keep the video short because I had a technical problem. So can you see that properly? So okay, let's get straight into it. This is part 2. So part 1 was finding the support reactions, included finding the support reactions. This is part C, using the method of resolution of joints. Calculate the axial forces in the members of this truss and state whether each axial force is in tension or compression. 12 marks. So you got 1, 2, 3, 4, 6, 7, 8, 9 members. 12 marks. They say they call it method of resolution of joints. I thought it was called equilibrium of joints, but same thing basically. So just a refresher, sign convention is x equals x is horizontal axis, left to right is positive, y is the vertical axis, bottom to top is positive, moment about z, which is like the third axis, the axis that comes out of the page. So that's anti-clockwise is positive. So here's a diagram of the structure. Here we go. So we got 2 bay pin frame. So we found out RA. Oops, that should actually be the other way around. Yeah. So that was tension reaction here. Then we got a positive reaction here for RFH and RF. So that was 40. Sorry, minus 40 was RAH. 40 was RFH. RFV is 20. Point load of 20. All the other information I went over is 2 bays of 4 meters wide each, 4 meter high, 8 meter long. Then altogether, pin at F, roller pin in vertical at A. So let's start at joint A. Now, when you're doing this, you always pick the first joint you resolve is the one that has the least number of unknowns, because then you can make sure that you're correct. If, for example, if you started with if you start at RF, you could go wrong because you've got 3 unknowns, EF, BF, AF. If you start at member A, you've got AB and AF only, or even if you start at D, to be honest, you could start at D because you've got two unknowns. But or you can so I say start at A because I just worked out the support reaction. So let's start at member A. Let's zoom back in. Let's start at joint A. Let's start at joint A because we only have 2 unknowns at this point. So at A, we got our pin roller support, a member AB. Here's a diagram of the arrangement. So we've got a member AB here in detail, member AF here. There's a pinned roller here. So there's a support reaction here that was well, basically from right to left, which is negative, RAH. So here there's a free body diagram of the joint. This is force AB, force AF, and this is the reaction. So if we start by saying, let's take vertical equilibrium, then member AF equals 0. Member AF equals 0 because there's no other forces around. So actually that one goes to almost 0. Then we can do, now I did vertical reactions first because I just wanted to show that AF was 0. So then we do horizontal equilibrium minus RAH plus member force AB equals 0. Therefore rearrange RAH equals member AB force equals 40 kilonewtons tension. Oh yeah, so here's a note about notes. A note about direction, tension or compression. In this case, member AB is in tension because the force is away from the joint. If the force was towards the joint, then the member would be in compression. Remember this is very important. Yeah, just remember that because AB is away from the joint, that means tension. If it goes towards the joint, then it's compression. That's the most important thing of this, one of the really important things about this basic thing. Oh yeah, so another note is member AF is redundant because there is no vertical reaction at A. Okay, so that's basically joint A is solved. Okay, so let's move on to joint F, support, because, oh yeah, so now we've done joint A is done. So that we could go to B, but then we got 1, 2, 3 unknowns again. So let's go to F instead, because now we know AF. Now we've only got 2 unknowns, BF, EF. So let's move on to joint F, support, because we know the directions there and the member force AF is now known. So only 2 member forces are known. So therefore we can solve it. So here's the arrangement diagram on the left. So we got the pin joint, pin AF here, BF here, EF here. That's 0. That is at 45 degrees. That should be because it's 4 meters high by 4 meters wide. Therefore, tan alpha equals opposite over adjacent equals 4 divided by 4 equals 1. Arctan 1 is 45, but I've done that later on. And here's the equilibrium of the joint diagram. So we've got RFH going that way. That's 40, we found in the last video. RFV is 20 up. Then we got, then we got BF. It could be either way. So at the moment, the reason why I drew it like that straight away, because if we look at, we've got to make a quick judgment. This RFV is going upwards. And we know we've got to have equilibrium of the joint. So that means that there must be a vertical force going downwards, and there's no other vertical forces. So that probably means that BF is downwards. And then the other one, you could put it in the other way. If you weren't sure, you could put them all positive to start with and see what you get. But it's just that I use some intuition based on looking at the structure. We know that that one's 40, that the reaction is 40 from left to right. So at joint F, have to start with the vertical equilibrium, as there is only one unknown force, that of vertical component of member BF. Therefore, sum of vertical flotation. Here's the force diagram for. Oh yeah, this is for the force only, the vertical forces only. RF must be equal, so RFV minus vertical component of member BF equals 0. Oh yeah, so member BF, we were saying for the vertical part, I've drawn it as say it is compression. The arrow is coming into the joint. So this diagonal force is made up of a vertical component and a horizontal component. So member BF force is a vertical component and then a horizontal component. So it's the same thing as vectors, isn't it, in mathematics? Vertical member force BF goes from here to here. Therefore, this vertical component must be down this way, and then to close the triangle, this horizontal component must be going from right to left. So they're the direct. So that's how I'm working out. This is why I'm having to do this, because I need the vertical component of member BF, so that I can find the vertical reactions. The vertical component member BF of member BF is equal to RF. So if I rearrange this equation, then I get RFV equals vertical component member AF equals, and that is 20. Oh yeah, so it's just to, so now, so the angle of BF to the horizontal is, so here's the little trig diagram. There's opposite over adjacent angle alpha. That's the hypotenuse. We have a right angle triangle. So the right angle triangle, oh wow, trig would apply if it was not a right angle triangle, but with this one, it might help us to know this is a right angle triangle. This is the vertical, this is the horizontal. So tan alpha, we're trying to find alpha now, the angle, equals opposite over adjacent equals 4 meters high by 4 meters wide equals 1, taken from the truss geometry. Alpha degrees equals arctan 1 equals 45 degrees. So this is very easy. I mean, they're giving you a chance because maybe this is only year 1 BN joiners. This is very simple. So if the vertical component of AF, it should say as vertical component of AF equals 20. Now find the member force AF force. So sine alpha equals vertical component of BF. Sine alpha equals opposite over hypotenuse. Sine alpha equals a vertical component of BF over BF. Sine alpha equals vertical component of BF over member force AF. Oop. That should be BF. Sorry, BF. So the member force BF equals vertical component of BF divided by sine alpha. Sine alpha, sine 45.7071. Member force BF is equal to 20 divided by 0.7071 equals 28.2845, 4 decimal places. Okay, so some people could just say it's 28.3 or 28.28, but I found with some of these questions that if you make it too many low DPs straight away, sometimes you lose some of the information. So let's say I would typically say keep it to 4 decimal places. It's probably enough that it wouldn't cause an error in the other numbers if you using that number later on. So basically there you have it. That means that we found the vertical component of member BF is 20, therefore member BF is equal, the value of member BF force is 28.284, and that is a compression force because it's going towards the joint. And that was just my assumption. If this is like equation 1, basically. If you draw it the other, if you say that it's the other way around, then RFV plus vertical component member BF equals 0. Then you have RVF equals minus vertical component member AF. So RF goes upwards, so therefore you'd still find that the vertical component of member BF goes downwards because it'll be minus RF. So you'd get there in the end. It's just that I did it a bit quicker because I used an educated guess as to which way it would be when I set them up. You can do that as well. If you can see that, okay, the reaction's going from left to right, horizontal, and up and down to up, then obviously member BF is got to be going downwards because it's got to balance. Okay, so now, so the member force BF is 28.2845. Now we need to find the other. So if we're looking for the horizontal component of BF, cos alpha equals adjacent over hypotenuse. Cos alpha equals the horizontal component of BF over member BF force. Therefore, member force times AF. Oops, sorry. That's cos alpha equals horizontal component of BF over member force BF. Therefore, member force times BF cos alpha equals horizontal component of BF. Cos alpha equals 0.7071. That's also the same as sine alpha, because in this case, alpha equals 45 degrees. Therefore, the horizontal component of BF equals 0.7071 times 28.2845. That's 20 kilonewtons. So, there you have it. We've totally solved member BF force. It's 28.8 compression. Now let's take horizontal equilibrium of the joint. Go back to the diagram. So RFH is from left to right. So now here's another bit where you can use your common sense. Now you've got BF. So the right to left value of BF, the horizontal component of BF is only 20, but RFH is 40. Therefore, it's likely that EF goes from right to left, because 40 minus 20 still gives you 20. So let's do it properly, write it out properly. RFH minus H component of member BF minus member EF equals 0. Note quickly, look at the situation. RFH equals 40, H component of member BF equals 20, therefore member EF must be negative. So if we rearrange it, RFH minus H component of member BF equals member EF. Member EF therefore equals 40 minus 20 or 20, which is okay. So it's 20 kilonewtons. 20 kilonewtons from right to left. If we just do a quick check on that, check tan alpha equals 1, because tan 45 equals 1. So tan equals opposite over adjacent. Equals, it's found the wrong way. Hold on. Just a sec. So, tan alpha equals opposite over adjacent equals vertical component of BF divided by horizontal component of BF. Therefore, the horizontal component of BF equals the vertical component of BF, and that's 20. So this checks that they're both equal to 20. Oh wow! So this video is already almost 20 minutes long. As you know, this joint is totally solved. So we found all the forces at joint B as well now. Let's move on to, now I've put joint B, but we may even move on to, we could now move on to joint B, because we've got BF and AB. That means there's only two unknowns. There's two unknowns at B. That's BC and BE. So if we could choose, or we can go to D, because D will have, there's only two unknowns at D as well. So we got a choice. So if you want to know which way I'm going to do it, please tune into the next video, because as you know, I had some technical issues with the videos. On this Samsung phone, I recorded one and then it got corrupted. I had to spend like a few hours trying to recover it. It's a real nuisance. So I've got to keep the videos under 20 minutes, because even at 20 minutes, these videos are like 2 gigabytes. Unless someone can tell me a way of making them smaller, I would appreciate some technical advice. Actually, if anyone knows, can help me, leave a comment how I can get the videos a bit smaller. Okay, so see you in the final part of the series for the rest of the solution. I hope you enjoyed the video and found it educational. Remember those points I said. Really important was, the most important thing about equilibrium of joints, of if you've got the force coming towards the joint, then it's compression, and if it goes away, then it's tension. That's probably one thing. If you remember that, you're gonna if you, I mean, conversely, if you got that wrong, you're gonna fail every exam, everything. So just remember it, that rule, that if it goes into the joint, it is compression, and if it goes away from the joint, it's tension. Please like this video, please subscribe to the channel, please donate and support the channel if you can. Thanks for watching, hope you learned something. I did, and tune in to the next video for the completion of this question. Bye.